And we're back. We have the incredible honor of having a meteorologist from the other end of the country with us today. His name is Noah Bergren. He's a meteorologist in Paducah, Kentucky. Noah, welcome.
Thank you, Sam. I really appreciate you having me today.
Well, we're tickled to death you had the time to visit with us. Uh, we wanted to have you in because you know exactly where we are in Tulsa and Claremore area of Oklahoma. You guys have been getting some really bad weather out there, and for the most part, Oklahoma has been spared, which is almost a reversal. Any explanation for the harsh February that a lot of the folks, including yourself, got hit with?
Yeah, it's been a wild 2 months, and it's featured everything from winter weather to severe weather. Looking back at the winter of this past year, a quick 3-point summary for you. If those of you watching are not familiar, we had La Nina conditions in the Pacific Ocean. When we look to forecast sub-seasonally, we're talking a few weeks to a few months in advance. We look at the state of the ocean temperatures in the Pacific. You've probably heard your local meteorologist refer to that before. La Nina, El Nino. La Nina is cooler than average. That's what carried over from the hurricane season and helped fuel the big active winter of weather. And we got slammed in February. I say holy February around here. Not just this part of the country, Oklahoma, Texas, the deep south. A historic cold snap that will be remembered for years, really. And this one is interesting. The last one here, Sam, we were expecting during La Nina to get an uptick in tornadoes. We actually did not. We had our fair share of snow and cold. But generally during La Nina winters, this part of the country gets more tornadoes from the warmer weather and the jet stream pattern. And this year was actually quiet in terms of tornadoes in the winter. So that was the only surprising spot. But if you will, I mean, it was the 10 days we had here. I remember telling people on air, it's going to be something that we reminisce about. You remember that year and that week back in February of 21? It's going to be something. It's a new benchmark for cold in this part of the country.
Do you think we'll see it again?
Oh, sure, of course. And
Yeah.
The best thing about computer modeling nowadays is that we can run analogs of these things. And, this is actually something we knew that was coming. I'll talk about this in a couple of graphics from now. I've got to talk about the polar vortex, but certainly, yeah.
Well, it was an extremely harsh February here, and it was for a great large portion of the country as well. And I have to admit, not as a meteorologist, but just as a regular observer of the business, it struck me that the eastern end of the United States really get hit much harder than we did, which is unusual.
It is unusual, and we'll talk about this too more. I've got a couple of graphics we'll hit up about severe weather, but how Tornado Alley might be shifting east. But the way that the jet set up, it just favored the eastern United States this winter, and it's certainly something that raised a lot of eyebrows, and unfortunately, I think is going to become more common in winters to come in the next few years. Now, in terms of around here this winter, Sam, in Paducah, Kentucky, for those of you who don't know, I jokingly refer to us as the Midwest South. We're nestled right along the bottom of the Ohio River. Those of you who might not have been to Western Kentucky before, it's really an interesting part of the country. A lot of old river towns. The Ohio meets the Mississippi and the confluence, and we get a mix of everything: ice storms, snowstorms, and tropical remnants. But in terms of biggest one-day snowstorms ever, February 15th in Paducah, 9 inches. That will be the 5th biggest one-day snowstorm we've ever gotten here. So certainly it will be something we remember for a long time.
I have a friend who is a meteorologist out in Denver. We were talking the other day, and he said, the shift in weather patterns has so affected the folks in the Denver area that there's a new business about to open up called saddles for mosquitoes. The mosquitoes are so large now that the folks think they can ride them. I want to run something by and I'm not trying to put you in a position of politics. And I know this is going to have the sound of it, but that's not what I'm after. You'll understand. climate change. We had a lot of folks in the political spectrum denied it at first. And all of a sudden, when it became so increasingly obvious that even a first grader could understand it, that some of them came in grudgingly still. But it's still controversial in Oklahoma, of course, with some groups. It is real, though, is it not?
It is real. And I will tell you, Sam, that what I tell viewers here, and we live in a part of the country where the impacts of a warming climate are different than, say, the East Coast. But what I tell people is, yes, the climate is changing. Yes, the climate always has changed. Yes, the climate always will change. The alarming part is not the fact that it is changing. The alarming part is the rate of which we are warming. And it is unfortunate that science has become a polarizing topic. Emily, if you can click forward to the next graphic here on 19, we've got a graph of the global temperature. We compare temperature in the modern era to the pre-industrial revolution, so 1881 to 1910. And I think it's pretty obvious, Sam. I mean, the viewers watching this at home, every bar on here is the annual temperature departure from average since 1880. And you notice some of the hottest years we've ever reported have happened in the past 15 years. Now, it's interesting, too, the fastest warming season, both in Tulsa, Oklahoma, in all of the eastern United States, is actually winter. The fastest warming season is winter. So in a warming climate, there will be less snow each winter. But, back to your point, Sam, about the controversial aspect. And as a broadcaster, I don't want to say I have to tread lightly, but it's not my job. This is my opinion. I might have a slightly different opinion than other broadcast Mets with this. It's not my job to tell people what to believe. I don't want to force things down onto people. I want to give people a fair look at the science. These are the numbers. Our climate is warming. It's warming faster than it ever has before. We are getting more heavy downpours. The tropics are more active. Now, in a warming climate, it doesn't necessarily mean more hurricanes. It means more stronger hurricanes from the warmer ocean temperatures. The CO2 is at the highest level it's ever been on Earth. I mean, it's undeniable the fact that we are changing. And I tried to shift the debate as to the long-term impacts, because everybody still wants to get hung up on over the fact of whether we are changing or not. And remember, the carbon dioxide, how long it lasts in the atmosphere, over 1,000 years. Nitrous oxide is only about 100 years, and methane about 10 years. And it is very strongly correlated, CO2, with temperature. And real quick, Sam, this is the chart. Now, a lot of the things I get being a broadcaster is, and let's be honest, I'm sure you can understand what I'm going to mean by this next statement. The climate's always changed. Why are we worried now? Well, here's 800,000 years of CO2 on Earth. Now, we get this from ice cores in the Antarctic. Look back from 800,000 years ago, you see natural swings, up, down, and parts per million. It's the huge uptick in the past 200 years, historic highs with the amount of CO2 on Earth. It is undeniable the fact that we are changing. And I try to focus on more about telling people that, yes, we are changing, but the research is more about how bad is it going to be in the future? What impacts is this going to be for the next generation, the next two around here?
Well, it's intriguing. Sunday morning, my wife and I were watching I think it was on CBS, a news program, and they were talking about all of a sudden folks along the eastern seaboard are harvesting seaweed.
Yep.
And it's proving to be a futuristic thing, but it's already catching on as a food source. And they say by the year 2050, it will have replaced the potato. I mean, that's hard for us to imagine, but we're looking at things now that were food sources. We've lost a lot of farmland in the western part of the United States because there's just no water. In fact, our aquifer, the one that runs underneath Oklahoma, is halfway down and there's no way to replenish it. But back on message here. In your opinion, do you think Tornado Alley has shifted east, or is it just perception?
I think it's actually a combination of both. And Emily, if you could pull up my graphic that's 27, Sam, I've got a great image here for you. Uh, Tornado Alley. You guys in Oklahoma, right? You always think about, oh, I live in Tornado Alley, Oklahoma, Kansas, Nebraska, North Texas. Well, the term Tornado Alley is mildly misleading because this is a graph from the Capital Weather Gang with the Washington Post of all of the areas that get tornadoes, the tornado warning polygons. Notice really from the Great Lakes to Florida to here in Western Kentucky and West Tennessee to the Carolinas. Is it really accurate? And this has been something that has been brought to the forefront with research in recent years and with the broadcast community. Is it really fair to say Tornado Alley is in Oklahoma or in Texas? Yes and no, because Tornado Alley happens everywhere. I mean, really, the Eastern United States is Tornado Alley. That being said, if you click forward to Emily, the number of tornado days is shifting east. So far this year, we're below average. This is a chart of the tornadoes this year. You see the red line there, that's 2021. We're below average in terms of tornado counts. But on the next one, you can see that the environment for tornadoes is moving east. Now, Sam, what I'll tell you is there's two big things. There's more people living in the southeast, so there's more people being able to report tornadoes, which is why I say it could be misleading because there's more people in these areas to report tornadoes than say there were 50 years ago. So our ability to observe these things is much more now than it was a few years ago. And also, the temperatures in the eastern United States, especially in the Mississippi Valley, are warming more. And also, the drought is different in the plains with you guys. And so you combine changing precip trends in Oklahoma, warming Mississippi Valley, and more people out here to observe tornadoes. So, yes, the number of tornado days might be, in the past 30 years or so, more, let's say, in Kentucky than in Oklahoma. But I'd say it's inconclusive. That's my personal opinion.
Well, let me dance over to another question here because time is our biggest enemy. You, as a broadcaster, know that better than I. Have the cuts at the National Weather Service impacted meteorologists across the country?
Undeniably, 100%, Sam. And this is another thing that is unfortunate as a scientist, as a meteorologist, because science should be agreed upon and shared unanimously. Everybody should agree with science. Everybody should understand and respect science in terms of the climate change.
Oh, God bless you. I'm so glad to hear you say that.
And with the National Weather Service. And it's unfortunate that science has become thrown into the political spectrum because when that happens, especially with something natural like the weather that impacts all of us, it hurts the public when we can't agree on science. And in terms of the Weather Service funding, there's parts of the Deep South that don't have radars. There's radar holes in Alabama where, on tornado days, meteorologists can't get a good view of storms because there's no radars. The servers for the National Weather Service, every time you pull up a forecast on your phone, a weather app, if you watch the Tulsa TV markets, a lot of this data originates from the National Weather Service. And that system is so outdated, it is on the brink of a collapse.
So the new weather satellite didn't help that much.
Oh, that helped, but we need investment and improvements here on the ground before more up there, in my opinion. And it's only a matter of time until the Weather Service system has a huge catastrophe during an active day. Just imagine during a high-risk day in Oklahoma, if the Weather Service radars and the ability to send tornado warnings went out. That would raise a lot of eyebrows.
Well, that brings me to another point. Will meteorologists such as yourself and others across the United States start to rely on their own forecast instead of the National Weather Service?
Maybe more so. There certainly is a big push with TV, as I'm sure you are aware. TV is a fastly changing environment, faster, quicker, cheaper, better, shorter, more to the point, clicks for online. And on that narrative, there's a race with some markets and TV stations to put warnings out before the other people. And in my opinion, that hurts the public. We, as the broadcaster, should not be stepping into the ring of the National Weather Service. They are the ones who should be issuing tornado warnings. Now, that being said, if a station or a broadcaster wants to try to cut in on TV before there might be a tornado warning, try to give an extra lead time and say, hey, there's no official warning yet, but this has my attention. It could very well and likely will have a warning soon. We'll give you an early heads up. But in terms of a station issuing their own tornado warning, I think that is over the line in the sand, if you will, of the role of the Weather Service in the broadcast community.
I'm dating myself, and I had a wonderful time. I got to tell you. Now, I'm dating myself when I say this, but when I first broke into the business, the weatherman, if you will, who was not a meteorologist, would rely on weather radar from an old military plane that the station engineer had installed, and that was being done all across the country. Today, the tools available to men and women such as yourself, who are highly trained and highly knowledgeable, is astounding. You have such incredible tools at your fingertips.
Really, Sam, you think about it, 30 years ago, not even 30 years ago, before we had what's called dual polarization radar, unless there was a storm chaser or a human who saw a tornado and reported it in, there was no way to know real time just by looking at a radar image that there was a tornado on the ground. I mean, confirmation. We've got the ability now, as many of you have probably heard, tornado debris signature, debris ball, correlation coefficient. It's amazing the lead time advancement and the ability to see debris in the atmosphere before, somebody might be able to see a tornado. That is the biggest thing, is being able to know just by sitting at a computer without seeing outside that there's a tornado ongoing.
No, I have to share one more thing with you before we start moving toward the end of this get together. I was at home the day this happened and saw it unfold, but when the monster tornado destroyed Moore, Oklahoma, the weather folks over there had a picture of it coming toward Oklahoma. And the folks in Oklahoma had a chopper in the air and had a picture of it leaving that part of Oklahoma headed this way. So we had shots from both sides. And I remember I was just mesmerized standing in my den watching this dual coverage. But what was really intriguing was what is being said from a broadcaster standpoint behind the scenes. We had a split screen situation and we had split duties. The chief meteorologist and the chief news anchor were working together, communicating facts, warnings. It was the most intense hour and a half I've ever seen.
There's nothing more challenging than covering that extreme weather and tornadoes in that part of the country. And serious kudos. I tip my hat to all of the meteorologists who do that. They are world class who do that, and the news departments there as well.
Do you mind if I ask you to pull in for a second and kind of look into your magic ball? You and I have seen a lot in our short time in the industry. What do you think's coming in terms of tools? What are we going to have to work with down the road, or the young folks that are going to follow us?
That's a great question. I'll give you two things. The first is new radar technology. There's something called phased array radar that's being developed by the Weather Service, the private industry. That's going to help lead to better, help increase the lead times for tornadoes and severe weather. But I really think that the advancement's going to come from the private industry, like you see with a lot of sectors. SpaceX, with going into space. I really think that in terms of media, weather, and communication, there's going to be a huge boom. I mean, you're already seeing it. I mean, everybody's got one of these. I mean, the second that there is a tornado on the ground, somebody sees it with a phone and is live streaming it, or an iPad. And
Yep.
and IBM just came out with their first computer model that takes in weather data from iPhones with the barometer that's built into the new latest generation iPhones. That gets fed into what's called the graph computer model, which you see on local TV stations. So, and that's a whole private thing, but that is going to help lead to huge advancements in the future of numerical weather prediction. Having weather points from everybody's device, what the pressure and the temperature, is wherever they are. So
The future is just so intense. I know that there's a big experiment underway in California to use holograms for sports, and you'll be able to see in your living room football plays in the floor, if you can imagine, with players about 3 feet tall. Noah, thank you. We're out of time, but thank you for sharing your time with us, and keep up the good work out there, my friend.
appreciate you having me. Enjoyed it.
Talk to you another time. Folks, we're all out of time. Thank you for joining us, and we'll see you next time.